It's wonderful to see the energy in the room. Good afternoon, everyone, and welcome. Welcome. It really is a true joy to have you with us as we come together to celebrate Harvey Mudd's 70th anniversary. This is a milestone that is made possible by our extraordinary community. We are thrilled to have so many trustees, faculty, staff, alumni, parents, friends, including members of the Mudd and Platt family with us here today. All of you, your presence makes this milestone even more meaningful because Mudd has always been defined by the people in this community. It's the people who bring our mission to life. For 7 decades, Harvey Mudd has been at the forefront of STEM education and discovery. From the beginning, our mission has gone beyond technical excellence. We prepare leaders who master their disciplines and understand the societal and ethical impacts of their work. That distinctive combination of engineering, science, mathematics, and humanities, social sciences, and the arts has shaped our graduates and helped them to tackle some of the world's most complex challenges. Today's symposium is both a celebration and a call to the future. We'll look back on signature initiatives like the clinic program, which pioneered real-world, team-based problem solving. We'll look at entrepreneurship programs, which have sparked student and alumni ventures. And we'll look back on the summer research program, which has opened pathways to advanced discovery and graduate study. We'll hear about sponsored research at Harvey Mudd, its development, its impact, and its vital role in our achieving the new Carnegie classification for research colleges and universities. At the same time, we'll share bold new initiatives, including our Innovation Accelerator, part of our STEM for a Better World strategic plan. This plan lays out an ambitious vision for the next decade, advancing 21st century STEM education, creating centers of excellence in fields like climate, health, and computing, building a new Innovation Accelerator laboratories, and ensuring that Harvey Mudd remains accessible, inclusive, and transformative for generations to come. So today is more than just a reflection on our past. It's a chance to imagine that bold future, one where Harvey Mudd continues to push boundaries in teaching, research, and community building. I'm especially honored to lead a conversation with our distinguished guest, Dr. David Agus. Dr. Agus is one of the world's leading physicians and pioneering biomedical researchers. He is the founding CEO of Ellison Medical Institute and a professor of medicine and engineering at USC. A renowned oncologist, he and his team are dedicated to developing technologies that help doctors make healthcare decisions tailored to individual needs. He serves in leadership roles at the World Economic Forum, co-chairs the Global Health Security Consortium, contributes regularly to CBS News, and is the author of 3 New York Times bestsellers. His most recent book, The Book of Animal Secrets, Nature's Lessons for a Long and Happy Life, was published in December of 2023, and I've enjoyed reading many of those lessons over my morning coffee. I truly commend it. Our conversation will explore the intersection of science, technology and society, an area that resonates deeply with Harvey Mudd's mission and our vision for the future. So thank you again for being here to share this milestone with us. Let's dive into the program and be inspired by the past, present, and future of Harvey Mudd College. David, please join me on stage. Well, again, David, welcome. It's so good to have you here.
Thank you, Harriet. It's great to be here.
Campus. This is very exciting for us. Shall we just jump right into it?
Yeah, I mean, listen, we've had a connection for several years now to Mudd because your graduates work at our institute and they're rock stars. I mean, so literally, I'm here to recruit more.
Okay, all right, you got it. You got it. You got it. Well, I have so many areas that I want to cover with you, but I want to start by just understanding the frontier a little bit. You know, at Harvey Mudd, we've long believed that the most exciting ideas and solutions to real challenges emerge at the intersections where engineering, science, and the humanities really come together. Now, your own work spans medicine, technology, entrepreneurship, engineering, investments, and that really resonates with the way we strive to prepare our students. So I'd like to start by asking this. What do you believe are the most promising frontiers that will require this kind of cross-disciplinary innovation? And maybe you could share a few examples that really illustrate where this is already beginning to take shape.
You know, it's funny, when kids are in college or they're in high school or any university, they have to choose a discipline. I'm going to study physics, math. Well, the real world is not divided into physics, math, and engineering. They're all combined, right? Every problem we face on this globe is going to be a hybrid, and learning how to think is the role of a university. Once you learn how to think at college, then you apply it, and it's got to be cross-disciplinary. So, you know, early on, I realized in medicine we were too focused on biology, right? We became reductionist. And Walter Isaacson, who wrote the amazing biography on from Steve Jobs to Elon Musk and others, called me up once. He goes, listen, I want to do a PBS special, David, where Murray Gell-Mann interviews you on cancer. I go, Murray Gell-Mann, he's like the greatest living physicist. You know, he discovered the quark and string theory. He won the Nobel Prize in 1969 when I was 4. And he goes, yeah, him. I go, all right. So Murray and I meet, and you know, the first thing you ask an amazing physicist is, do you ever meet Einstein? And his response was pretty cool. He goes, yeah, we were once at a conference, and we went to the bar afterwards, and we had a discussion, actually an argument about this. You got in a bar fight with Einstein? He goes, no. I go, yes, it's cool. It was a fight, an argument in a bar. And so, you know, we talked for a couple of days, and then we had this PBS thing. And the first thing I noticed was, you sit down, the smartest guy in the world, and he would have his questions listed out like you, but underneath each in capital letters, and I guarantee you don't have this, it said, remember to smile. So I love the fact that the smartest guy in the world had to be reminded to smile.
Wow.
And he started to say things to me like, you know, your field is all about the median, the averages. The key in physics is we look at the outliers. And that's how we learn, right? What if the patient had a dramatic response or no response? And that's how you learn. You don't look in the middle to find it. He would say, you know, our field, we realize very quickly, and you haven't figured this out yet, is that too many details is bad. You have to do something called coarse graining. You know, it comes from photography. I take the lens of a camera and I make it blurry, and all I need to know is the outline to know you're a human. Right. If I count every pore, every hair in your head, so much data, I'm not gonna figure it out. So you coarse grain things. When you were sick, your mother went like this. She didn't draw your blood, look at your T cell activation, your interleukin levels, right? This is a coarse-grained element of biology that tells you if you're sick or not. And by the way, it's probably a lot more accurate than if I tried to gene sequence your T cells. It would be very confusing. And so now we've kind of transitioned. We try to coarse-grain things to do our models and think like a physicist applied to biology. And that's been transformative. You know, we always see now at colleges that, you know, there's a transition, right? My kids were not that much older than the current undergraduates. You know, they graduated 4, 5, 6 years ago. You know, computer science was hot, right? Now all of a sudden, AI can code. So you don't need to code anymore, right? You need to be able to think. And so there's a transition. When I trained at Hopkins, I went to my head of medicine, and he said, David, what are you going to go into? And I looked at him, and I goes, I'm going to go into cancer. And he looked at me and goes, are you crazy? Cancer is giving poisons to people. It's kind of barbaric. You're smart. Go into cardiology or pulmonary or renal where you can make a difference. Go into this old school field. I was the first person in history to go from Hopkins to Sloan Kettering, the biggest cancer center in the country. Yeah. And so to me, it kind of doubled my resolve. Go to where people aren't. So my emphasis for every kid today is, it's like that Wayne Gretzky quote, you don't go where the puck is, you go to where it's going to be. Is go to the fields that aren't hot today, but will be hot. Go to where the people aren't, and then apply your way of thinking to those fields. And by the way, you look at almost every major advance, it's from somebody who studied one thing and applied it to another. Elon Musk's PhD is in physics, and he applied that to other fields, and he created the world's leader in automation, robotics, and others. That's how we have to think.
This, I would like for us to take maybe one step further and help us see, maybe from your own work examples, or from your work, or from your work at Ellison Medical Institute. What are some of the examples of perhaps projects or one or two exciting innovations that really illustrate the need for this cross-disciplinary innovation that are going on today, that you're excited about today?
I made a drug for breast cancer that's now on the market. And it took me 10 years to make and 7 years to test. Now, at the Institute, and especially those two sitting right there, Jing Yao and Naeem, who lead the programs, we can actually use AI and say, hey, I want to develop something that binds to right here. Here's every other protein in the body. I don't want it to bind to those. Here are the genes for metabolism. I want it to last this long in the blood. Here are the genes for the immune system I don't want to recognize. And with those constraints, we can make a drug. So now literally we can make a drug in months. And the probability of success is dramatically higher than, quote, the old days. But at the same time, we're able to take it into humans very, very quickly. And what these guys did, I'm embarrassing them, which is good, by the way. It's very good to embarrass other people. What these guys did is they say, listen, people out there have won a Nobel Prize last year for designing a way to look at the structure of protein. Let's take all of the software out there, let's put it together in one platform where we can optimize on whatever parameter we want and start to make these drugs and take them into patients. So we have a drug for prostate cancer, for breast cancer, for inflammation in the pipeline, and it's very exciting that we can do this. At the same time, the other half of AI is saying, hey, listen, there's a lot of data, right? Obviously, we all go to a doctor. Our doctors, myself included, just dictate something or write something. And our electronic health records are bags of words. Well, now, with large language models, we can convert that to data and analyze it. And get a load of this. Recently, it was shown that the shingles vaccine, right, which blocks against recurrence of chickenpox, reduced Alzheimer's by almost 50%. So all the Nobel laureates, hundreds of billions of dollars, got Alzheimer's wrong. It's not just plaques in the brains. It's an immune response to a virus that affects neurons that leads to inflammation, that leads to the plaques, that leads to Alzheimer's. You block the virus, you don't get it. There'll probably be 2 or 3 viruses that come out from it. That's crazy and powerful, and these are done by 20-year-olds. It's totally inappropriate that younger kids are this smart. We have to kind of fix that. But it's wild, the transition. I really believe that if you and I can stay healthy over the next 3 years or 4 years, we can probably live 10 to 15 years longer because of AI.
Wow, wow. Now, when I visited you in Santa Monica, you shared a bit of that research on the protective nature of the shingles vaccine. And I'll tell on myself here a little bit. I was about, in years overdue. It's advised at 50, right, that you do the shingles vaccine. I was in years overdue, and you mentioned that to me, and that was motivating for me. I was out in within a month or two and got my shingles vaccine. And so I just put that out there that, you know, this intersection of knowledge, right? What motivates one person, and learning the same from your book of animal secrets too. I mean, there are all sorts of
Well,
ways.
get a load of this.
Yeah.
And don't tell anybody this. Is obviously we've got some.
This isn't taped or anything.
Good.
Yeah.
We've got some relatively controversial people now leading health in the government. And so
Off script.
it's hard to challenge them because it's very hard to prove a negative, right? And so we just started a project actually a few weeks ago where 25 years ago we looked for viruses associated with cancer, and we found a couple. Now with AI, we have whole new ways of looking. So we teamed up with a group at the Broad at Harvard, and we said, hey, listen, let's use all of the new AI to try to say, are there some viruses associated more with cancer? What better way, like we motivated you with the shingles? We know now that, you know, COVID can accelerate cancer. Having the flu can increase cancer and heart disease risk in a decade. Who knows what else is there? 100% of multiple sclerosis now is a virus. And so it's pretty wild. So by learning these things, again, I want to push people to the right thing. To get normative behavior change, you need leadership, and we're sorely lacking it in our space. You know, the virus is kind of wild. Josh Lederberg, one of the greatest thinkers of the last decade, actually a doc who did the first experiments with AI called Dendril on protein structure. He said the only thing that threatens man's and women's dominance on this earth is the virus. It is our wits, our brains versus their genome. Over 1 million years of evolution, the human genome changed 1%. The virus can change 1% in a day.
Wow. Incredibly motivating. And, you know, so through our connections, you're aware of the work that we've been doing with the Innovation Accelerator work and the Innovation Accelerator Lab for Emerging Health Technologies that Naeem is involved in. And we've had some conversations about the need for us to, here at Mudd, to prepare students for a broad base of careers in health technologies, in data design and tech. And, you know, so I think if we can take that at its surface, if we can take that, what I'd really like to get into is, if you will, the parallel work that we should be doing at Harvey Mudd and what we should be doing at institutions like ours to ensure that these human values and these societal values remain at the center of the breakthroughs that we are, you know, so eagerly pursuing now with AI and other technologies.
It's pretty cool, right? When you look at it, there are remarkable schools all over the world, but 95% of the great startups happen here in the United States. Why? Because we have a broad education. Even though we target STEM, we also target the humanities at the same time, and we make people learn how to think. Whereas other places in other parts of the world, you choose your career at Oxford and Cambridge as soon as you go in. And it's a little bit different. At the same time, you know, COVID happened and shut down the world. And it was pretty amazing, you know, a lot of negative from COVID. You know, we all changed. It really hurt many people. And it expanded many of the disadvantages that exist in this country. But one of the greatest things it did was it created a new generation of people, students, young people, who wanted to do meaningful work. So I will tell you that our positions now, probably 100x number of applicants than before COVID, because people want to do things that are meaningful. I look at Jing Yao here, who graduated Harvey Mudd in what year? 2020, and she went, pre-COVID, went to work at a company called Yelp. You could argue that it's probably not the most meaningful thing for humanity, but it's a good company. But then transitioning now to work on cancer research, obviously is pretty powerful. And I'm proud of that, and I'm proud of her. And I think it's exciting, right? The reason we're here on this earth is to help other people. The reason all of us went to university is to train for a career to help others. The reason you start a company is to help your community, period. You don't start a company to enrich yourself. You start a company to enrich your community. And that's the value system that we have to push. And so what's exciting is, you know, at the Institute, we designed our building. And it's kind of cool because every wall is glass, and the clinic and the lab are together. So every patient, when they come in, walks by the lab, and they see people working. That's hope personified. The researchers meet the patients, and they don't go home that night. And it's wildly powerful. We did this wild experiment recently where we took organs that were meant for donation and turned out to be ineligible. So a liver that was about to be given for a transplant, and for some reason or another wasn't eligible. And now with the device, we can keep it alive for a week or two. And we could test human drugs against a human liver instead of in a mouse. So it's game-changing in many regards. But the emotion of the kids who are managing it, 24 hours, they have to take care of it. And to see this came out of a human that literally died the day before, and to watch their face, realizing the impact of what they did, it's profound. And that's what I believe in. The way we get and educate kids to do something meaningful is we just show them the work and its impact. I want the patients to come by the lab and talk to the researchers every day. And that's what matters, right? I'm running an institute that is staffed by many Mudders, and it's not an institute that has a 10-year goal. I have a one-day goal, is I want to help people. And if there's something new that comes out, we'll change and pivot right away to get that into patients as quick as we can to help them.
Tremendously exciting, tremendously exciting. I want to pivot here and talk a little bit more about impact as well. You know about Harvey Mudd now, and we're excited to have you on campus to understand more of what we're doing and this amazing community that our students really, as a residential liberal arts STEM college, our students are here living together, learning together, and challenging one another on the ideas of this moment. What is important for our society right now? Our Division of Student Affairs is just, co-educators who engage, develop, and support. This is as important, I think, for formation. I frequently say I want students to be good at STEM and good at life. So with that kind of as a backdrop, how would you say, or what do you say is really vital in our students engaging with mechanisms, experiences that help them understand the globe, help them understand the importance of this education being broadly accessible, help them to understand the importance of living in community with one another? So I'm moving a little bit from the science and the values to the good at life part. Any thoughts or remarks?
First of all, it's kind of cool to talk to a university president with gold shoes. There aren't that many, I have to say. It's very unique, and I love it. Yeah, I mean, we're in a different world, right? The world is connected, the world is flat, as Tom Friedman says. Is that anything that happens anywhere affects us, right? When you look now, and I do a lot on the global health side, and people say, well, we have problems in the US, why are we helping global health? Because, the bottom line is if Africa does better economically, we do better. Disease, a virus in China can affect us, obviously. And so all of those is we are interconnected and we have to help each other. It's funny, I wrote a piece during the Biden administration when he was putting injunctions on China. And I wrote it with the CDC director of China, George Gao. And what we were writing about for the New York Times was that, in World War II, the US and the UK developed penicillin, and they decided to share it with nobody. And there are about 210,000 deaths attributed to the fact that they didn't share penicillin. So we wrote that we should be exempted in medicine and health technologies from this embargo they had put basically on China. And the Biden administration said, you can't publish that, and they wouldn't let me. Then with the new administration, I went to Trump, and they said the same thing. And then the New York Times editor, one of them called me up and goes, David, I know there's a firewall. They actually called it a Chinese wall, which is kind of humorous. And they said that I'm not supposed to know this, but I know both administrations. Turns out I want to do a piece on it. And I go, why? They go, to bring attention to it. I go, the reason I wrote it is to push the administration to think broadly on health. And by the way, them turning it down means they read it and they're thinking about it. So I achieved my goal. My goal wasn't people paying attention to it. My goal was the administration to learn about it, and they did, and we actually have a discourse on it now. So I don't need the adulation or people looking at me that I wrote it. I just want to get things done. And so in today's world, I mean, the mantra really is not necessarily, unfortunately many people, they want to stand up and protest and rally. The goal is to change things. And it isn't always the simple route, just joining in and screaming. Many times it's working behind the scenes. And in order to do that, you need a broad range. It's kind of wild. 11 years ago now, I wrote to the then president of Italy, and I said, one of your 11 national treasures, I think we showed it to you, is this sculpture, and I want someone to make a copy of it for my institute because it's so meaningful to me. He wrote me back a letter basically saying, I don't know if I say this on camera, but F you. So, years later, I helped roll out the COVID vaccine for the EU, and the then president, actually his diligence, found this letter, and he said, we're going to have our national sculpture as a thanks make this for you. And it was very meaningful because it's about a country doctor in the UK named Edward Jenner, who had noticed that women who milked cows, only women could milk cows because they had smaller hands at the time. They would get pox on their arm. They could take care of people with smallpox. At the time, it's killing 11% of the world, and they wouldn't die. They were the only ones. So he went to the King of England and said, hey, listen, I want to stick a needle in, draw pus out of their arm, and inject other people. And the king said, you are crazy, get the hell out of here. He goes, I'll inject myself. And the king said, leave. That night, the king thought about another king, King Solomon, where two women went to King Solomon and said, this is my child. And they both argued over the child. And King Solomon said, I'm going to rip the baby in half. And then the real mother said, you take the child. So that empathy, he knew who the mother was. And he called this guy back, Jenner, and goes, you have one child. Your wife died of smallpox. You have a 5-year-old child. You inject your child, I'll know you believe. So the sculpture is Edward Jenner injecting his child, which then was the first vaccine equivalent. But why it was meaningful to me was not because of that. It's because the second through 11th person who got it was the king and the royal family. So science without leadership dies. And so in today's world, we need leaders. We need people like your students who are going to get up and lead by example, who can lead and push the world in the directions we need. Because if you haven't noticed, we're in a really difficult spot on the globe today, and it is tough. And media, social media are kind of knocking down leaders, and we need to build them back up. And we need a generation of leaders that can and will change the world.
Absolutely. I so agree with that. I really received that, David. And, I think one of our challenges, one of the things that we have to continue to grapple with here is how we continue to inculcate that in our students when there is just so much for them to do academically. How do we make sure that they have time to engage with the world, understand the world? How do we bring that through example? How do we bring that through opportunities for them to engage? And so I know we've had, again, a few students come to Ellison Medical Institute and have done amazing work with you. Do you have suggestions or ideas or examples that we might draw from in drawing them into this conversation about the world?
Well, listen, your clinic program is the coolest thing ever. The notion that you could take undergraduates and not just say, hey, listen, go on a tour of the Institute, but come up with a problem. We actually put out resources to pay for them to do it, and then use that problem solving to help other people. As an undergraduate, it's the wildest thing in the world. Because I don't want them to look at a problem as a discrete thing. They have to realize that it's not just the problem, how scalable it is, how you manufacture it, how do you make it so that there's users can actually use it, how do you make it so it's aesthetically pretty, all of those aspects, and they do it, and they work on it. And we have remarkable mentors, led by Jing Yao and Naeem and others at the Institute that enable them to do that. And this year it's the coolest thing. Am I allowed to say what they're doing, or is it secret? Oh. Obviously many of you have been to doctor's offices, and no offense to us, but they're horribly inefficient and don't work well. So what we decided to do was RFID label everything from the patient, you wear a band, to the doctors, to the actual tube of blood. So imagine coming in, first of all, I know where everybody is. At the end of the day, I can look at all the workflow. Was it efficient? How long did somebody wait? And make that better. But also, when I go into a patient's room and I say, hey, that tube of their blood has a minute left till I get results, I'll wait a minute so I can go in and talk about the results of the blood draw, right? I know what's going on. We were doing it, Apple was initially working with us, and I said, listen, I want to know 5 minutes before the patient's here so I can get the room ready, they don't have to wait, because you're waiting in a doctor's office, no matter how much privacy you want, somebody knows you're waiting in a cancer doctor's office that you probably have cancer. So Apple said, well, we can't have any privacy. People will know where they are. They don't want us to know where they are. But I said, I don't know where they are. I just want to know when they're 5 minutes out, right? Because that doesn't tell me anything on privacy. It just knows they're 5 minutes away. And so we can get things set up so that they can have their privacy, things can run efficiently. So the students are going to build the software to run it. And then work on technical problems. How do you geolocate where they are in the room, where the tube is, in what machine? And so it's remarkable problems. Then a user interface, so doctors and nurses who are normally not very technologically sophisticated, as Ravi can tell you, how do we get them to be able to use it? And that's what's wild. So giving them real problems is the coolest thing in the world. These are not just textbooks problems. These are problems that we're going to use that people can help. So first of all, it gives them pride. Second of all, you hate to have to say this, but they have to realize, hey, the reason I need to learn about math is in order to geolocate somebody, I have to triangulate and all this. This is why all that advanced calculus makes sense. And so it's kind of wild that we have to do that, but it really gives them the reason to do what they do.
No. It really is those real world experiences, which, as you know, Clinic has been on the forefront of doing that. I just want to probe that if you have a remark just a little bit further around the mindsets that they need. I think I'm hearing from you that you appreciate that they bring this technical excellence and technical strength to problems. Would you say there are certain, if you're interviewing Mudders, I'll frame it this way, if you're interviewing our Mudd students, are there certain mindsets or experiences or skill sets that you are especially looking for as you think about people who are going to help advance medicine and public health?
It's funny because it's a little bit embarrassing to say it with parents in the room. But if I want to look at somebody, I want someone who is passionate about what they do, who isn't going into something because their parents want them to. And that's very hard if you think about it, right? Many kids want to do something to make their parents happy. But if you're going to have a career, hopefully it's going to be for 50 or 60 years, you have to love it. So I want to see passion, right? A lot of kids go into something they're good at, not necessarily passionate about. Go the easiest route. I'm good at math, I'll go into math. I still remember the day where my daughter came into my room in high school and said, Dad, it's really sad. I go, what do you mean? She goes, I want to like English and history, but I like math. I go, that's not bad. It's a good thing. And she goes, well, all my friends love English and history. I go, but it's okay to be different. And I want to see that passion. And all too often, people choose things because they think it's hot, because they think it's the right thing to do. It's going to be a good salary. My parents want me to do this. But in order to succeed at something, you have to love it. And then you also have to love the personality of the people in it, right? Every field has a certain personality, even within medicine, right? Nephrologists are different than cancer docs, are different than surgeons, are different than neurosurgeons. You have to love the people in it because that's who you're going to work with for the next multiple decades. And so I want to see that passion. And so, a lot of parents probably hate me because we've changed a lot of kids' minds and direction of what they want to do by pushing them. What do you love? Well, I love this, but this is a more secure path for a career. I go, I don't care about that. I don't want you to do what you love. And that's what matters. And so, university, college is a place to try things, right? Do different things. Look at art. Look at history. Look at math. Look at engineering. And wherever that passion is, go that route. And I think we have to really enable kids to take passion and take risk.
I also heard you say about you have to love the other people that you're working with, and that we know collaboration is so vital. And that's one of the things that we pride ourselves on here, that it's collaboration over competition. that it really is about Mudd students helping other students to be successful. Can you say a little bit about, I know you have a couple of stories on that too. Could you share your experiences in collaboration?
We're at a time in the world where most of the low-lying fruit is done. So the projects that are going to receive are team science, team projects working together.
Right.
And if you're a professor at Harvey Mudd, you get promoted by how you teach, how you grant you get, or the research you do. I want to change things. I once had a woman I was trying to promote, and the provost called me and goes, David, I'm not sure she has the criteria to be promoted. I go, really? Why? Well, she doesn't have independent stuff. I go, you see that elevator there? Your institution wouldn't run without it. He goes, yes, of course. And I go, well, without her, these major projects wouldn't happen. And we need to start to promote people and find criteria for team science, for team working together. And I want, when I choose kids for a project, I get in trouble when I use the word kids, and I apologize. When I choose young adults for a project, I want people who are doers, I want people who are innovators, and I want people who are leaders. You put all of them together, you get real results. You put a bunch of leaders together, it doesn't always work. You put a bunch of innovators, nothing gets done. And so the real critical thing is to have that mix, and for you as an individual to realize that you fit into one of those buckets. And they're all amazing, those buckets. Every single one of them, one isn't better than the other. But the hybrid together is where we're going to make those advances. And I think that's what's pretty amazing. I was privileged, to take care of some remarkable people in my lifetime. And, to sit with people, I was up 2 weeks ago, I went up to Palo Alto, and I went and I met Elon because he wanted to show me Optimus, the robots they make. And it was amazing, first of all, to see them, because you walk into a room, and there are 200 of them, each being trained on a separate task, and it's reinforcement learning. They were opening and shutting a curtain 1,000 times, and they go to the next task and the next task. And they're pretty amazing. I have an elderly mother, and she lives alone. This now, the robot will help her walk and walk the dog so she doesn't fall, go to the bathroom at night. She likes to cook, so it will shop and prep. She cooks, and it cleans up for her. But what was amazing to me is afterwards, I went to the every 2-week update meeting where Elon met with his team. And who is invited to the meeting is everybody who made progress in the last 2 weeks. So a 19-year-old intern presents what they did versus a department head. And the department head presents a little bit more because they accomplished more. The 19-year-old presents what they did. And just to see, first of all, the pride and the fear and the learning. So it's not the division head saying, here's what my division did. It's every single person who did it is presenting. I learned something from every person I interact with. Every management style. I would watch Steve Jobs with his management, and Steve had, what Walter Isaacson called the reality distortion field. He would, act as if the project was going to work, and it worked, right? He would convince them that it could work, and they found out a way to do it. And it was wild to watch these people. These weren't, at the time, at Apple, the greatest engineers in the world, but they had the greatest leader in the world, and that made up for it, because he made them together do work that nobody else could do. And it was wild and inspirational to watch. Leaders, I think I told you that, during COVID, I was privileged to take care of Colin Powell. And Colin was public that he had myeloma. He had a kind of cancer. And he got COVID. And I had called him up and said, listen, I arranged for you to get an antibody, which were new at the time. And they were limiting its supply, a monoclonal antibody, because you're immune suppressed, and this COVID can threaten your life. And he said to me, David, I will never cut the line. I won't get something that every other troop can't get, and because of my position, I won't cut. He died 5 days later of COVID. But it just was his passion, and his value system was, I can't do that. And he didn't regret it, even as he got sicker. It was the right thing to do. And so, in my field, every decision is based on the value system of the individual. And I want to make sure that our kids, again, I apologize for that word, our young adults, I get in trouble all the time, and you get mean looks when I say kids. Our young adults, we're teaching them their value system matters. And their value system is not something they learn from others. They have to learn to themselves. And it takes a while to really understand it. And it's not something that they just want to jump on board. I want them to really understand where those values come from. And so we want to put them in those uncomfortable experiences where they're going to have to learn and develop them.
Yeah, absolutely. Well, this has been a wide-ranging conversation, from spanning boundaries to talking about AI to
Gold shoes.
gold shoes to value system to collaborating together, and really the work that we do that's important is that which is in service of one another. So I want to thank you for being here, sharing that with us. Please help me thank Dr. David Agus today.
Well, thank you. Thank you. I mean, thank the trustees for enabling this to happen, the family for enabling this to happen here at Harvey Mudd, and especially for the parents for trusting their kids to go into this kind of situation. Yeah. The clinic program is scary for kids, right? They're thrown into a very advanced corporate setting where they have to work on a problem where there's a lot of dollars and a lot riding on them. And so thank you, parents, for allowing your kids to do that. Because it benefits us, and it's amazing to watch them mature during this process.
It is amazing faculty who are leading that, amazing partners who are who from our industry partners to NGOs who are working with us to make these opportunities available. And it really is, as we'll hear later in the symposium, a model that has been both admired and replicated at many universities and colleges across the country. But I would dare say that no one is doing it better than Harvey Mudd, and certainly, really, as I have shared, I've been in higher ed now for 30 years and worked at a number of institutions, and have seen graduate students who are amazing in their fields, and seen our undergraduate students be able to really hold court on that same playing field when it comes to advanced discovery. And a part of that is because we have amazing students, we have a wonderful community, we have brilliant faculty who are helping that happen, and we're very grateful to our partners as well. So thank you again, David, for coming and sharing your thoughts with us today.